In this video, we will be answering the question on the screen from the 2022 Ordinary Level Maths exam, paper 1. If you are looking for any other questions from this paper, there will be a link in the description to a playlist that will have them all. And this is question 7, the first of the larger questions in this paper. You have to answer 2 and you have a choice of 3, I think. This question is going to be about functions, graphs, some differentiation, and lots of little questions. That's what you can expect in these bigger questions, from lots of different parts of the curriculum, and lots of strange little questions, always trying to trick you, trying to ease out all your knowledge, trying to make sure if you get an A, you deserve an A. It's basically what these questions are about. Okay, so part A gives you this table here, and it tells you to fill in the rest of them. They tell you time is x is in this function here. They give you this function. They tell you a whole story about what's going on in this question. This is somebody's heartbeat, H for heartbeat, the function of heartbeat. X is the time, and the time goes between 0 and 6 seconds. Later on, the questions are going to ask us more about this time here. So all we need to do to get these numbers, they've given us 3 of them, is put x in. Time is x in this case. Put the number for x into this function. If we put the number 1 in here, got a calculator and did all this out, we'd get 160. So we can go ahead and do this. We can put 0 in. 0 we can actually do in our head. 0 to the power of 3 is still 0. 0 multiplied by anything is 0, so that's all 0. Again here, it's all 0. 0 times anything is all 0. So we're actually just left with plus 158. So 158 goes in there. 2, I'll do 2 out a little slower, and then I'll use a calculator to do these last ones here. Put 2 into this formula. We get H2 is equal to minus 0.382 to the power of 3 plus 2.6 times 2 to the power of 2 minus 0.13 times 2 plus 158. So again, everywhere we see an x, we're just going to put a 2 in. That's all you have to do for all of these numbers. Put the numbers in everywhere. If you're good at a calculator, do all this in one go. If not, do each term separately. 2 times 2 times 2 is 8. 8 times this. I think I've done these numbers. I have, okay. This is minus 3.04. This one will be plus 10.4. Here will be minus 0.26. Plus 158. If we add all that together, I don't have the number here actually. We get a number close to 165. And they tell us to round off to the nearest whole number. So the answer to this was probably 165.2 or something like that, and we rounded it off to the nearest number. Okay, 3 is already done for us. 4, we do the same way. I won't waste all of our time doing it here. I'll just give you the answer. Is 175. Pause the video and try that yourself. And for 5 is also 175. Okay, the next thing they want us to do, now that we have all these numbers, is to put them on the graph. They've already put A here, which is 169. They want us to put the rest of these numbers. So time is the x-axis, x or time. The y-axis here is y, or it's BPM, beats per minute or heart rate. And they just ask us to put these numbers in. X is 0. Here's 0 on the axis. Oh, they did write that in for us. 0. 0 and 158. So we go to 0, we go to 158, and there we put a dot in. Do the same for all of these. 1 and 60, dot here. 2 and 165. My graph's not going to look that great because I've done it on a board with no rulers or anything like that. 4 and 175 about here, and 5 and 175 about here. And they ask us not just to put the points on, but to draw a graph. So they expect us to put in a line. Use a pencil for this because they do want you to be quite accurate. They want you to be smooth, and they don't want you to miss the points by very much. Don't worry, you don't have to be an artist, but use a pencil, give it 1 or 2 goes. Do it slowly, go through each and every point. So that's what they want, something along those lines. Now on to part B. Part B probably tripped up a lot of students because they asked you, I'm trying to read it correctly here, explain what the coordinates of the point A 6, 169 represent in the context of Joseph's heart rate. So that's who the person we're talking about here, Joseph. So explain what point A means. They want an English sentence here. They want you to say something along the lines of, it is 6 minutes into his run. So here's 6 minutes, the time was in minutes. It's 6 minutes into his run, and his heart rate is at 169. That's all. They want some sort of English of that. So 6 minutes into exercise, I think it was. Exercise. And heart rate 169. They don't care about English. They don't care your sentence is good. They don't care how long your sentence is. They want to see the word 6 minutes, maybe at start of exercise, something about exercise. Honestly, 6 minutes would be full marks, and heart rate 169, that'd be full marks. Some sort of English sentence around that. That's all they wanted there. Okay, for part C, another strange one, but easy if you understand what's going on in the graph. They want you to continue drawing the graph. I'm trying to read it here as I speak. After the point A. So what happens after this? Because they're giving us more time here. So they tell us his heart rate stays at the same level for the next 2 minutes. So at 6 minutes it's 169. That means at 7 minutes it's 169, and at 8 minutes it's 169. So that's what it looks like there for the next 2 minutes. Then after that, they say it decreases at a steady rate of 10 beats per minute for 2 minutes. Okay, so we're at 8 minutes here. It goes down 10. So at 9 we should be at 159. And at 10 we should be at 149. So something like that. And this should be a straight line. So that's what steadily decreases should look like. So that's what they want, just to draw a straight line and another straight line going down. And they will ask questions like that every year in the exam. They'll ask you to understand how a graph works. They'll ask you, like in part B, they asked us to turn a graph into English. And part C, they're asking us to turn English into a graph. It'll come up. Practice, look at lots of questions, read your book, ask people like me or your teacher questions. Hopefully you should get there. Okay, for part D, well first I just want to remind you this heart rate, this formula for a heart rate. Lots of things can be put into formulas, and we see that again for part D. There's another formula for his calories this time. So the amount of calories amount of calories burned per minute. This formula, and most of you probably would know that the more your heart rate goes, the faster your heart rate's going, the more calories you're probably burning. So it makes sense that the calories burned depends on the heart rate. You don't really need to know most of that for this question. They simply ask you to find out using the graph or the table. I'll use the graph since I've rubbed the table out. How many calories he's burning per minute 6 minutes into the training session. So 6 minutes into the training session. Well, that's easy enough to do. It's calories burning after 6 minutes. They give you a time, put the time in. X, they told you X's time is equal to 0.1 H times, I've already put 6 in up here. That should have been an X up here at the start. I put 6 in for X, and then minus 7. Okay, you could go ahead and put 6 into this formula up here, which we've already done that, and we did it, or they did it for us in fact. 6 was, his heart rate after 6 minutes was 169 minus 7. Put this into a calculator or do it in your head. This is 16.9 minus 7 is 9.9. Yep, okay, is 9.9. And that's the answer. Do they want us to round that off at all? No, so 9.9 calories being burnt per minute. Okay, next question, part E. Wow, this is another really tricky one. They tell us he starts training at 2:55. He stops training at 3:23. So that's a total of 28 minutes. And then they tell us he's wearing a watch that beeps every 15 seconds. How many times does it beep in his training session? It says it beeps when he starts his training and it beeps at the end of his training. How long? So first of all, every 15 seconds, that's 4 times every minute. So I think most people would probably just guess 4 multiplied by 28. Do that in a calculator and we get 112. Boom, final answer, 112. You're going to lose some marks there because that's not actually right. That's maybe too small. I'm going to use a new one here. We'll just go 1 minute, 2 minutes. Yeah, we'll just use 2 minutes here. And again, for 28 minutes multiplied by 4, 112 beeps. What if I asked you for 1 minute, how many times was it going to beep? The start and at the end of the run. Again, we'd guess 4 times 1 is 4, or for 2 minutes we'd guess it'd beep 8 times. We can just test that. 15 seconds is here, 30 seconds, 45 seconds, 1 minute 15, 1 minute 30, 1 minute 45. So how many beeps do we see? It beeps at the start. Beeps at the start. That's 1, 2, 3, 4, 5 beeps in the first minute. If we were to stay going, 6, 7, 8, 9. 9 beeps after 2 minutes. So it's not multiplied by 4. It's multiplied by 4 plus 1. The extra one, the start was an extra one. That only gets counted once actually. So the full answer here, 28 minutes would be this plus 1. So 113 beeps. You could just go ahead and count. I'd say a lot of students, you might see a lot of students doing this at the side of a page, just counting up to 113. Wouldn't be that bad. Use the graph here again. You could just start counting up to 10 minutes and hopefully you'd notice that it's 5, then 9, then 13. So after 28 minutes would be 113. Okay, on to the last part, part F. They give us this formula here, h derivative, the derivative of h, x is equal to minus 1.14 x squared plus 5.2x minus 0.13 equals 0. And they ask us to solve that. So that's all we need to know partially. Well, there is one little trick at the end. Is that they go on, they tell us more. They tell us this is the derivative of this first one here. So that's actually useful to know, and yeah, that's all. Oh, they tell us this is going to find the maximum. We want to solve this to try and find the maximum of this formula. So they were quite nice to us here because they might not have done this for us. They could have asked us to differentiate this on our own. So that's quite nice of them. And they didn't have to put an equal 0 here. They might not have put that there for us either. What you might see, and you probably will see some years, is they'd ask us to find the maximum of this formula. And when you hear the word maximum and equations, we should be thinking differentiation and we should be thinking equal 0. So they've helped us a bit out here. Okay, with that said, let's go ahead and try and solve this formula. This has an x squared, x, no x. This is a quadratic formula. We solve hundreds of these, thousands of these when you're in school. So you have to get used to it. How do you solve a quadratic formula? Sometimes we try and factorize it. We try and break it into two things that multiply to get this or that or whatever. But this is a really difficult one. You're not going to factorize this one in your head. So there's a much better way to do it. We're going to use the quadratic formula. Now hopefully you all remember the quadratic formula. If not, it's written in your tables. This formula is given to you in the exam. It's minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now what's a, b and c? A is equal to this number in front of the x squared. Don't forget the minus. Minus 1.14. B, the number in front of the x. If there's a minus, don't forget it. There's not here. 5.2. And c is the number here at the end. And again, don't forget the minus. Minus 0.13. So the quadratic formula means we have to solve it twice. We have to do it with a plus and we have to do it with a minus. I'll do it with a plus first, and then I'll just give you the answer for the minus. It's going to be the same way. So x is equal to minus b is minus 5.2 plus, we'll just use plus the first time, square root of b squared, 5.2 squared, minus 4 times a. So I'll put a bracket around the a because it's a minus, and then times c, which again I'm running out of room here, minus 0.13. Oh, all of this is divided by 2 times a, which is 2 times this number here. 2 multiplied by minus 1.14. Okay, if you're really good at calculators, go ahead and put all that into a calculator. But first let me say, some people go ahead and put this into a calculator without writing it down. That's a big mistake. The examiner will, if you make a mistake, the examiner will take lots of marks off. If you get everything right, you're fine. But if you go ahead and write this down and I've left a little mistake somewhere there, I'm going to still be okay. The examiner will see what I was thinking and they'll give me nearly all the marks. So okay, go ahead and put this into a calculator, or do some of the parts first. Like lots of students would feel much more comfortable doing out some of these parts first. So minus, let me move that down, equals minus 5.2 plus 5.2 squared is 27.04. Multiplied minus 4 times minus 1.14 times minus 0.13. 3 minuses make a minus, and those numbers come out as 0.5928. All of this is over minus 2.28. And again, put this into a calculator, get the square root of it, add or take minus 5.2 away, and stay going down as slowly or as fastly as you feel comfortable with. You should get an answer of 0.025. Again, you have to do all this again. You got to put all this with instead of a plus, there's a minus. If you did it slowly, you should have a number here would be the same. This number would be the same. This number will be the same. You just change this to a minus. Either way, however you do it, you put it into a calculator and you get x equals 4.54. Okay, 2 answers. You often get 2 answers for a quadratic formula. Although the question says this, give your answer in minutes. Now the exam doesn't make mistakes, well, rarely makes mistakes. It didn't say give your answers. It didn't have a plural on the word answer. They only want 1 answer, and we've gone ahead and got 2 answers. So you're going to have to tell me which of these is correct. And to do that, I've left the graph up here. X is equal to 0.025. Well, here's x, 0, that's somewhere down here. That's somewhere really close to the start. Is that the maximum? Doesn't look like a maximum to me. And how about x is equal to 4.54? That's about there. That looks like a maximum. Okay, so what's happening down here? My drawing's a little off. It should have actually looked like, let me rub this out. It should have started here and looked like that. And there would be the minimum. So When a derivative is equal to 0, it's either a maximum or the minimum. We've gone ahead and found both. We found a minimum and a maximum. We wouldn't know which is which without using the graph or without differentiating again. Would be another way to do it. Okay, that's hopefully that answers that question. If you have any follow-up questions on what's going on there, feel free to ask me in the comments. Hopefully I explained it okay. If not, like I said, ask me in the comments. Until next time, have a great day.